Bit of review. Tell me what cosine of A plus or minus B is. Without looking it up. I do not want you to look it up. I want you to try to do it from memory.
That's the difference formula, right?
Sum and difference. That's what the plus or minus means. This is going to cover anything that's a sum or a difference of two angles.
So I know the sine version better. I'm going to start with the sine.
Sine version.
The sine version's sine A times cosine B plus or minus sine B times cosine A.
Good. Now, the cosine version is actually easier to memorize. It's got two cosines in front, two sines in back. Tell me what it is.
It's cosine A times cosine B, but isn't it? It's minus plus, yeah, and then sine A cosine B, or sine B.
Or sine B, yeah. You see why that's easier? Because I had no decisions to make. In this one here, I actually had to decide whether that was A or B. And it's B. But it's the reason they teach you that one first and the sine one second, is because the cosine one has one less thing to remember. When you do the sine, you know it's sine cosine plus or minus sine cosine, but is it sine of A cosine of A, or is it sine of A cosine of B? So that's a little bit harder. And just remember that the angle changes within each product. So it's always A and B, B and A. And same up there. It's always A and B, A and B. In other words, no part of this is AA, BB. Okay? So that should help memorize it a little bit also. All right, now let's bring up our problems. And the only reason I said that is because we have a lot of problems today that require this. Hold on a second. Let's see, hold on. Sometimes I hate this program. I can't move this thing. There we go. Now I can close it out. And it's not covering up my scroll bar. And I need access to my scroll bar. All right, so we did a problem like this to end yesterday's session. And in fact, we may have done this one. I'm not sure if we got through 18 or 19. I think we only got through 18.
Yeah, I think it was 18.
Okay, well, this one is exactly the same. Only it's 18 was find the cosine of x minus y, I believe. Well, so this one is using a plus instead of a minus. The procedure doesn't change. Tell me what I need to do. What's always the first step in these kind of problems? Draw.
Yeah. We draw the triangle.
Okay. In this case, we got two triangles because we got an X angle and we got a Y angle. So whenever they give you two variables, you're going to need two triangles. These are both always right triangles. Whenever the first step is to draw a triangle, it's always a right triangle. Now, dimension the one on the left.
Okay, so that'd be 3 is the hypotenuse, and then 1 is the opposite.
And give me the bottom.
Square root of 4.
No.
Or no.
It's the hypotenuse squared minus the other side squared.
8.
Now dimension y. If the cosine of y is 1/3.
Hypotenuse is 3, adjacent's 1, and then opposite's square root of 8.
Now we want cosine of x plus y. Give me the, just working with that, tell me what that is equal to. And we want to use the plus or difference formula.
So it'd be cosine x times cosine y. And then be minus sine x times sine y.
You see why that's a little easier to memorize? I had no decisions to make on the second cosine. It had to be the opposite angle of the x. Whereas when you're doing the sine one, you have to make a decision there. All right, now let's figure out all 4 of these things. Tell me the cosine of x.
Square root of 8 over 3.
It's cosine of y.
Square root of 8 over 3.
No, cosine of y.
Or 1 over 3, sorry.
What's the sine of x?
1 over 3.
What's the sine of y?
Square root of 8 over 3.
That's the same thing as that. When you subtract something that's the same thing, you get 0. Ooh, that was our answer C. I think we did do that one yesterday. That's okay. It's worth reviewing. All right, let's go to 20. Now, it's going to be the first step. Whenever you see that, what's the first step?
Draw the triangle in a quadrant 2.
That's always a correct answer. Draw a right triangle and label what?
Hypotenuse is 5, and the opposite is 4.
Angle. I got 2 possible angles here. I could take that angle, I could take that angle. So you have to label the angle. That I'm going to call angle X. I could call this one up here angle X, but I always choose the lower right one. Okay? Now label the triangle. You can't label this triangle until you specify where X is.
So then 5 is the hypotenuse, and then 4 is the opposite.
So what's that make the other side?
3.
Okay. Now, they want to know sine of 2x. Well, I can't figure it out from my picture. But I do know the formula for the sine of 2x. What is the double angle formula?
Isn't it sine of 2x? I know the sine one, but I don't know the cosine
this is
one.
the sine one.
2 times sine x cosine x.
Perfect. The cosine one is harder because there's 3 different answers. But the sine one, this is the only one they use. If I said cosine of 2x, there are 3 different answers. So it's much harder to memorize. But we can work on that in a second. So this is what I want to work with, right? I only have this triangle. So tell me what 2 sine x cosine x is. What's the sine x?
4/5.
What's cosine x?
3/5.
What quadrant's it in?
2, so that'd be negative.
Now let's go back and talk about the sign. What is the sign in the second quadrant? Do we put the right plus or minus sign on it?
Sine is positive.
Correct, so we did. Now multiply all those together and you get minus 24 over 25. An answer right there. Okay, so the solution to all these types of problems is draw your triangles. If there's one variable, you got to draw one triangle. If there's two variables, you got to draw two triangles. And then you have to employ these double angle. Well, let's talk about double angle. There's two of them that you really have to memorize. One, and this one they start with the sine of a double angle because that's the easiest one to memorize. You've memorized that. The cosine is kind of the tricky one. And there's three things. And there's a reason there's three things. It's difficult to explain the reason until you get a little further into trig. But there's the first one. Okay? And that's not that hard to memorize. Cosine squared minus sine squared. There are two more. One deals with nothing but sine squared, and I think it's this. Do you have the book open by chance?
I do not. We don't have a book really. So.
And the other one looks like this. Let me open my book, double check, make sure I'm not giving you misinformation. I have a hard time memorizing these myself, but let me look, make sure I got it right. I think I do. Let's see, we're talking double angle. Double angle formula, 493.
Yeah, that's the same thing as in my notes.
Okay. Yeah, notice one way to help memorize this is to notice that you are subtracting in all three cases. And there's a lot of similarity. I mean, you kind of have to memorize this. And you kind of have to memorize this. But then the third one, looks a lot like the second one, only it uses cosine squared, but it's still subtraction, and it still has 2 times the trig function squared minus 1. Well, 2 and 3 are pretty closely related. So it's easy enough, not easy, it's difficult, obviously. I had to look it up in a book to be certain. But there you go. It's however you memorize those three is what you want to do. 20, which was the easy one. Let's look at 21. All right. Let me draw a unit circle here. Quadrant 1, 2, 3, 4. all students take calculus. That's all you need to know. In other words, if you are going to draw the unit circle, this is the most basic thing you need to know. There's a couple other things that are worth knowing, but I don't need them for this problem. What does that tell you?
That n is greater than or equal to 0.
Yeah, but what does that mean? Which quadrant is it in?
It's in 1.
Okay. So what they're saying is that x is in the first quadrant, and the cosine of x is equal to a. Okay, so we'll just make up an angle. We'll call that x. And whatever that angle is, the cosine is positive a. We'll find another solution to the equation. The cosine of some angle is equal to a. What is the equivalent? Which, first of all, is the quadrant where cosine is going to be positive? The other quadrant.
Quadrant 4.
Correct. So what they're really asking is, what is the angle in quadrant 4 that is the equivalent to x? Well, it's minus x. If I took the cosine of minus x, I would get a. Because it's the same reference angle, right? It's x in either case, but in quadrant 4 it's positive. In quadrant 1 it's positive. So it's the fourth quadrant angle that they are talking about. Now, how do I define the fourth quadrant angle with their answers? Do this a couple ways. Let's pick some numbers. That's 30 degrees. What's that?
330.
Okay. So 330 would be an answer for x. In other words, the cosine of 30 would be equal to a, and the cosine of 330 would be equal to a.
Wouldn't, I mean, like B would work, right?
Yes, so far it would. Right now, is that the only one that works? Yes. A does not work. C, 180 minus 30 is 150. That doesn't work. 180 plus 30 is 210. That doesn't work. But this one does. But just to be certain, pick some other angle other than 30.
60.
So if that angle's 60, what's the other angle have to be?
300.
So if n is 60, 2 pi, which is 360, minus 60 is 300. Boom, we got our answer. It's got to be B. Now, perhaps the key to this problem was writing a positive angle instead of a negative angle. In other words, the first time I did it, I used the positive angle. I knew that it had to look like that, and that was minus 30 degrees, so the positive angle had to be 330. If I'd used a negative angle, I'd still be working on this. So, I'm not sure what the moral is. I wouldn't say the moral of the story is to necessarily use positive angles, because your calculator always gives you negative angles. In other words, if you put into your calculator what's the cosine of minus 30 degrees, it's the same answer as what's the cosine of plus 330. And in fact, anytime you add a multiple of 360, you get the same answer. So there's another solution, which is to go around twice. So that angle would be 360 plus 330, 690. But they don't have that as one of the multiple choices. We don't need it. We found our answer. All right. Ooh, that's a good question here. Really good question. And it's not obvious as to how you solve it. You have any ideas? Let me see if you make the mistake that everybody makes. What would you do? How would you find that? What's your starting thing? If I said sine of x, if I told you sine of x equals 1/2, how would you solve for x?
Divide by x to both sides.
No.
Or no.
Talking trig here. You don't use algebraic techniques. You use inverse.
Inverse sine of 1/2 equals x.
Okay. So x equals inverse sine of 1/2. You're allowed to use your calculator. Tell me what that is.
Like 0.523.
No. What's the sine of 1/2? If there's one, or what's the sine of 30 degrees? If there is one trig angle, you want to know for one trig function, it's that one. What is the sine of 30 degrees?
It's like square root of 30.
No, it isn't. Your calculator's in the wrong mode again.
It's got to be in degree mode.
That's why it's so important to know what that is in your head. Because that
30.
you can always test your calculator and figure out whether it's in degree or radian mode. That TI Inspire is terrible for switching back and forth between degree and radian mode. So what angle is the sine of that angle equal to 1/2?
30 degrees.
Okay. So they want all of the answers in that interval. Well, we know 30 degrees is one. What's another one? Where else is the sine of an angle equal to 1/2? Your calculator doesn't tell you this because it's not the principal answer. The principal answer is the first quadrant answer. You put in a negative 1/2, you get a fourth quadrant answer. But there is another quadrant where the sine of that angle is equal to 1/2.
4. Or no, yeah, 4.
What's this angle right here?
$120.
150.
150.
In other words, it's always 180 minus theta. So if I want the equivalent angle in the second quadrant that's equal to a 30-degree angle, I take 180 minus 30. So this angle is 150. So 150 also satisfies this. Okay? With me? If you put into your calculator sine of 30, you'll get 1/2. If you put sine of 150, you'll get 1/2. Unfortunately, if you put the inverse sine of 1/2, you only get the first quadrant answer. Just the way calculators work, because they have to be functions. They have to be able to give you a single answer. You understand?
Mm-hmm.
Okay. Now, this has got a little extra beef to it. That was the simple problem I gave you. I said sine of x. So if I have the sine of 3x, use the same strategy and tell me what the next line is. Last time when I said sine of x equals 1/2, the next line was x equals the inverse sine of 1/2, correct?
Yeah.
While you're thinking about that, I'm going to go put in my lunch. Hold on 1 second. Give me 30 seconds.
Okay.
So what's the next line in solving this?
It should be 3 inverse sine.
No? Here's what we're doing. Let's talk about this, because this isn't always obvious. What we're doing is taking the inverse sine of both sides. Let me show you. Here's our equation, okay? So the way to solve this is to always take the inverse sine of both sides. And what do you get when you take the inverse sine of the left side?
3.
3x. You get whatever this argument is. So it's 3x equals the inverse sine of 1/2. So the inverse sine of 1/2, we've just discovered, is 30 degrees, and it's also 150 degrees in this interval. So if 3x is equal to 30 or 150, what is x equal to?
Oh.
3x is equal to 30. What is x equal to?
10.
3x is equal to 150. What is x equal to?
50.
Okay, there you go. Now, we made a big mistake. It's the obvious mistake that everybody makes. 90% of your classmates will make this mistake on this problem. I did it basically correct, but there's a little bit of a trick here. When they told me the interval was 0 to 2 pi, that's for x. So what is the interval for 3x?
Two pi over 3.
It's 0 to 6 pi. You got to multiply it by 3. In other words, if the interval for x is 0 to 2 pi, well, what's the interval for 3x? Multiply everything by 3, you get 0 to 6 pi. Okay? And that matters a lot, and here's why. Let's go back down to this. Let me rewrite this so I have some room to write. So over here I got 3x equals, so far, 30 degrees and 150 degrees. But that's only if I go out to 2 pi. I really have to go all the way to 6 pi. So give me the rest of them. There's a bunch more. I got to go out to 3 times 360. I got to go from 0 degrees to 1080 degrees. So give me the rest of the answers in that interval. In other words, our domain expanded by 3.
So one would be 390. And then, what is that,
510. You add 360 to each of your answers. Now, that goes out to 4 pi. We need 2 more.
So it'd be 720.
Add 360 to this.
So that'd be, let's see, 750. Okay.
Okay, and add 360 to 510.
So 870.
Okay. Notice is all I did was I add 360 to that, I added 360 to that, I added 360 to that, I added 360 to that. So there's my 6 answers for 3x. So now tell me what all of my answers for x are.
So it'd be 10 and 50.
Notice that all 6 of those answers are inside the unit circle. They're inside between 0 and 2 pi. Hold on one second.
Okay.
Hello? Wow, somebody thanking me for choosing Hilton hotels, but I didn't choose any Hilton hotels. I ain't going anywhere.
You don't want to go on a vacation?
Oh, I'd love to. I'd love to go choose Hilton hotels, but I just got a spam call thanking me for choosing them, which makes me think, I wonder what the heck's going on. Somebody steal my identity and make a reservation at a Hilton hotel? I don't know. All right. This problem illustrates 2 things. First of all, you have to be able to handle a multiple angle. But the way to handle it is real easy. You just take the inverse sine of both sides. So you get 3x equals the inverse sine of 1/2. Well, your calculator is going to give you the first quadrant answer. Your calculator is going to not give you that, but you can figure out that answer. But the real key to this problem is you have to expand their domain that they gave you. They gave you 0 to 2 pi. And notice that if we'd used 0 to 2 pi, we'd only come up with 2 answers. We'd have come up with that one and that one. To come up with the other 4 answers, you've got to recognize that the domain of 3x is 0 to 6 pi. Then you come up with all 6 of these answers, and then when you divide each one of them by 3, you get 6 answers that are all inside that interval. So there are 6. That is the correct answer. And this is about as tough, I won't say that. Trig can get awfully tough. But this is definitely a tough one. So let me just do something here. I want to make sure you understand this concept. So let me make one up similar. First step.
So it would have 8 solutions.
Yeah. First step. That's not really the first step. The first step is to solve for 4x. How do you solve for 4x?
Inverse cosine.
Okay, so 4x equals the inverse cosine of 1/2, which is what? In degrees?
30?
Use your calculator. Sine of 30 is 1/2. That means cosine of 30 cannot be 1/2.
$60.
Notice that is the complementary. It always is. If the sine of 29 is 0.4, then the cosine of 61 is 0.4. They're cofunctions. That's the definition of cofunction, is subtract the angle from 90, and the sine of that angle is the same as the cosine of 90 degrees minus that angle, always. So that's one answer for 4x. What's the second answer inside that interval right there? Where else is cosine of what angle is equal to positive 1/2? This is where your calculator doesn't do any good, because your calculator is not going to give you this. It's only going to tell you 60. But there's definitely another quadrant in the unit circle where it's equal to that. Which quadrant is it? Where's cosine positive?
Fourth quadrant.
Okay, so what is the fourth quadrant angle that is the same as 60?
300.
Okay, good. However, most people would stop right there, and their answer would be 15 degrees or 75 degrees. Well, you got to remember to do this. If the domain of x is between 2 pi and 0, tell me what the domain of 4x is.
It'd be 60, 300.
0 to what?
0 to 8 pi.
Yeah. So we have to answer this 4x problem all the way out to 8 pi. That's 4 unit circles. So let's just keep adding them. What's the next one? What's the second unit circle answers?
It'd be 420.
And?
660.
And the third unit circle answers?
780.
And?
1020.
And finally, the fourth unit circle, which goes all the way to 8 pi.
1140. Oh, and then 1,380.
Okay. So there's our 8 answers for 4x. All of them are correct. So now let's figure out x.
X equals, let's see,
Give me the first one, I'll do the rest.
15.
75, 105, 140, no, not 140, 145, 145. 4 goes into 660, 145. Okay, and then 4 goes into 780, 195. 4 goes into 1020, 255. 4 goes into 1140. What? You got the calculator. What's 1140 divided by 4?
285.
And finally, the last one. That's 1380 divided by 4.
345.
There are your 8 answers. Notice that every one of them is inside the unit circle.
660 should be, 660 divided by 4 is 165.
Ah, okay. Instead of what, 145?
Yeah.
Okay. So that's the way you handle these kind of problems. And they always throw in this little tricky part. In other words, they always tell you that x is between 0 and 2 pi. And the reason that's tricky is because that means 4x is between 0 and 8 pi. And you're solving, the first part of this problem is you're solving for 4x. You're not solving for x. To solve for 4x, you got to go out as far as the domain for 4x. So if this was 14x, I go all the way out to 14 pi. 7 or 14 times 2 pi, go all the way out to 28 pi. Okay? So I think you get that part. You feel like you do?
Yeah.
All right. So we did this one. What is this? This looks different. Now, hold on a second. I got to blow this down a little bit because I am... Yeah, I thought I was missing some information there. I was, the bottom part. Find alpha and x. Approximate your answers to the nearest hundredth. Give me an equation that lets me solve for alpha.
It's going to be tangent of A equals 15 over 20.
Solve that for alpha.
Alpha equals inverse tangent of 15 over 20. $36.8.
Keep going. Give it to me to 3 digits, 3 decimal places.
36.8698.
Okay, why did I ask to it for 3 places? So what's the answer?
36.87.
In order to figure out what that has to be, you have to get the 3rd place. You can't round it down or up until you know that 3rd decimal, which in this case is a 9. Okay? So 36.87 is the correct answer. 36.87. Okay. Now, And that makes sense. That certainly is a smaller angle than our 61-degree angle. All right, so give me an equation for solving for x. Always start the left side of your equation with the trig function you're going to use. What trig function are you going to use?
Tangent of 61 equals 15 over x.
Solve that. What's x equal to? Not
X equals,
it's equal to 15 over tan of 61. You can always do that step. In other words, just switch places. When the variable's in the denominator, just switch places, because I'm going to multiply both sides by x and I'm going to divide both sides by the tan of 61, right?
yep,
What's that answer?
.314.
Round it off to 8.31. What are the units on that? We talking degrees, radians, inches, centimeters?
Centimeters.
In other words, very important to distinguish in trig, you always want to distinguish between angles and side lengths. Side lengths are numbers. Angles are angles. They're not the same. You take trig functions of angles. The top 6 trig functions, you always take them of angles. And you get ratios. Just like you said the tan of alpha was equal to 15 over 20. That's true. And to solve for angles, you take inverse trig functions. We took the inverse trig function of 15 over 20. Notice that we take inverse trig functions of ratios to get angles. You always are solving for angles when you are taking inverse trig functions. You're always solving for ratios when you take trig functions. Perfect. Spacing. Hold on a second. About 10 minutes here. Okay, so no trig function in our final answer. All 3 of these lend themselves to the technique that I've tried to teach you. And I'm not sure there's any other technique that's better. What's the first thing I have to do to solve that?
Make it all like one.
Well, what's the normal answer when I say what's the first thing I have to do when we're talking trig?
Draw a triangle.
Okay. Now, is there any way to label that triangle and label theta? But before I label theta, it's very important to look at this problem and realize that that is an angle. The inverse tan of 2 is an angle, right?
Yeah.
Okay. Now, I can label this triangle based on this alone. If the inverse tangent of 2 equals theta, and that's what this means, what I'm trying to say there is the inverse tangent of 2 equals theta. So, what's the tangent of theta equal to? If that's true, and that's what I'm saying, is the first step in these problems is always to recognize that on the inside parentheses, that's an angle. That is theta. Now I can draw a triangle and I can begin to begin to dimension it. Well, if the inverse tangent of 2 equals theta, what's theta equal to?
63.4.
No. Don't use your calculator.
Don't.
Very important you understand this concept. If the inverse tangent of 2 equals theta, then what is the tangent of theta equal to? By definition. It's only one number to see on this page. What is it?
2.
That is by definition. If the tangent of theta equals 2, then the inverse tangent of 2 equals theta, right? I want to make sure you get that before we go on. Now, if I know the tangent of theta equals 2, help me dimension this triangle. Okay, I'm going to give you a hint. Tangent of theta is 2 over 1. Now dimension that triangle.
So the opposite's 2, adjacent's 1.
Okay. Remember to do that step. That's why I tell everybody that we take trig functions of angles to get ratios, not to get numbers, but we're always getting a ratio. And we take inverse trig functions of ratios to get angles. Well, 2 is not a ratio, but 2 over 1 is a ratio. So you have to make it a ratio. Once you make it a ratio, now you can dimension the triangle. What's the hypotenuse?
Yeah, just 4.
Zach, you got to get better at doing right triangles. Seriously. What's the hypotenuse? Always the answer starts out square root of
A squared plus B squared.
Correct, which is?
5.
Okay. When you're doing trig, you got to be able to solve a right triangle quick. If it takes you a long time to solve it, these are going to be deadly for you. They'll each take you 15 minutes to do. So the faster you can solve right triangles, the better off you're going to be. Okay, now, from here, it's a piece of cake. Because what we're taking is the cosine of theta, right? In other words, if I let the tangent, the inverse tangent of 2 be theta, then the problem says, well, what's the cosine of theta? Now read your triangle. What's the cosine of theta?
Square root of, or 1 over square root of 5.
Go ahead and put that into your calculator. We don't need to rationalize it because, oh, nope, we do need to rationalize it. Maybe not. I've seen other problems where they don't force you to rationalize it in your teacher, so this would be an acceptable answer. If I had to rationalize it, what would it be?
0.999.
No, rationalize it. That's not rationalizing it. Your answer should be exact. That means you don't round it off, you don't get rid of radical signs.
Oh, it'd be secant of
square root of 5 over 5. 1 over square root of 5 is square root of 5 over 5. 1 over square root of 2 is square root of 2 over 2. 1 over square root of 3 is square root of 3 over 3. These are all rationalized, meaning that I do not any longer have an irrational denominator. But trig doesn't care about that so much. So they're perfectly willing to accept an irrational denominator. Nowhere here did they tell you to convert to or round it off to anything. Your answer should be exact. It means you're not getting it out of a calculator. You're getting it from solving it and using the radical signs. Okay? Same exact problem is B and C. And I say that because it's the trig function of an inverse trig function. All three of these are the same. In other words, we don't have anything that looks like this. Right? That's kind of the opposite. That's an inverse trig function of a trig function. We could do those also. But so far, they haven't given us any of those. It's very important when you have the inverse on the inside to take this step right there. What's my first step on B?
Draw the triangle.
Okay, and not really my first step, but that's fine. Now what?
Inverse.
I have to recognize, what is the inverse cosine of x? Is that a ratio? Is that an angle? What is it?
X over 1.
No? Is that a ratio or an angle?
It's an angle.
Okay, let's call it theta. Now I can label theta. How can I dimension this triangle now? Remember, make that a ratio. Just like I made 2, the ratio 2 over 1. I do realize you have to leave here quickly, so if you have to run, just holler. Let's see if we can get through this problem. Dimension this triangle based on the fact that the inverse cosine of x equals theta. Okay, let me give you a hint. Make this the inverse cosine of x over 1. That's what theta is. Now dimension the triangle.
1's the hypotenuse and x is the adjacent.
Yeah, see how much more sense it makes if you turn everything into ratios. Now, what's the opposite side? What do I start my answer with always when I'm solving right triangles? Square root of. What is it the square root of?
It's x plus 1.
No. I'm not solving for the hypotenuse here. I'm solving for
1 minus x.
Right. 1 minus x squared. Remember, everything inside the radical sign has to be squared. Regardless of whether you're taking the hypotenuse squared minus the short side squared, or if you're solving for the hypotenuse, everything inside the radical sign is squared. Okay. Now, tell me what the sine of theta is, because that's the question. What is the sine of theta of this triangle?
Be the square root of 1 minus x squared over 1.
You got it. Now, you don't have to put the 1 underneath, but I actually prefer it because it tells you that you're getting a ratio for an answer. Right? All right. Tomorrow we'll start with 2C.
Okay.
Okay, Jack. I'll talk to you tomorrow.